Hi, I'm André Esterhuyse from Strand Hardware, and today we're going to look at what you can do with circular saw, things you should do, things you should not do, and let's hope you can learn something from it today. Right now, basically what I'm going to talk about is I'm going to start from the basics. In other words, if you're going to buy a circular saw, what are you going to look out for, etc., all of that. For you, those of you that want to upgrade, maybe you can also pick up a few tips there. Now, first of all, we sell the Toolmate brand of circular saws as well as the Jet brand of circular saws. This particular one is a Toolmate model, and as you can see, it comes with a nice solid cast iron top, which is what we normally want from a circular saw. The main thing is it must be a sturdy machine. You will quite often find that the ones that are pressed out of plate are much more noisy. The sound actually gets amplified, that kind of thing. It's not as heavy. In other words, when you actually cut, it tends to fall over, all of that. So bottom line is, buy yourself a fairly heavy machine. It actually forms the heart of any workshop. Once you've got a good circular saw, you can do wonders with it. Now, the basic function of a circular saw is really to rip wood lengthwise. In other words, cutting in the length of the timber as well as cross-cutting. That is the main function of a circular saw. Obviously, you will also need the physical blade to tilt to 45 degrees so that you can do angled cuts with it. Now, the different parts of a circular saw, if you look at this part, this is what we call the rip fence. And the rip fence is attached to the front and the back rails. And on the rip fence, you must have a good clamping function. If it doesn't clamp properly here, then obviously the back part will be out of alignment. And that is the critical part of a circular saw, and it's quite often the reason why people get frustrated with their saw, because when they set it and they clamp it, the line of the saw and the line of the blade, they are not parallel, and we actually want them to be parallel. In actual fact, if we place two straight edges on both of these, you want the fence to open up slightly towards the back. In other words, business card thickness opening up at the back and flush in front. That is the way it should be. In other words, not 100% parallel. The main reason for that is when you cut, you will get a downward force from the center of the blade to the front of the blade. But once your piece of wood goes beyond the center, you get to the back part an upward motion. In other words, if the wood is binding slightly at the back, you actually tend to get a bit of a kickback. That's why you want your fence to open up slightly towards the right-hand side. On this particular model, you've got your height adjustment here, and you've got your sideways adjustment hidden on the inside there. So what I suggest you do is that just look carefully at your fence. You will probably find on that narrow fence, on top there are two bolts. Just loosen them, then the fence can move to the left or to the right, and adjust it so that it's properly adjusted and lock it again. And also double check your locking device. That particular one that you've got will lock in front as well as at the back. Yeah, so just make your adjustment so that when you physically lock it, there's a positive grip at the back. Because if that grip tends to move the fence, then you've got to replace the fence. It's very, very dangerous to work with a fence which is actually going narrower towards the back. It's just simply calling for problems. As well as your fence, you also have a sliding miter gauge. And this sliding miter gauge is obviously there for cutting wood at 90 degrees or obviously on any angle between 45 and 90 degrees. Now you will also see that your table has got two grooves. That is a must. We will see later how these grooves can actually help you to make sleds and cut in a much more safer manner doing cross-cut work like that. Right, now as well as your motor at the back is obviously your source of power. It goes from a belt to your arbor in the middle, and then you have your basic circular saw. Now the arbor itself, some people get confused the way in which the nut is tightened. The simple rule is, if the arbor points to the right, it's a right hand thread. If the arbor points to the left, it's a left-hand thread. Okay? So quite often, the two saws may look exactly the same. We've got the situation now. This is a older model. The newer models came out with this whole assembly simply mirrored. In other words, the arbor is pointing to the left. To the left. So that thread will be a left-hand thread. So that is the rule. Points to the left, left-hand thread. Points to the right, a right-hand thread. Now, together with your arbors and all of that, you have your insert that goes around your saw blade, and that covers up the opening around the blade. And together with that, you've got your safety guard that fits over your blade, and you've got your riving knife behind it, which is a solid piece of metal. You will see the front part is slightly beveled, so that when your timber comes in, it lines it up exactly with the back part of the blade. Now, the alignment of that is critical. In other words, if you face it from the front, that blade and that splitter must be perfectly in line, not like that. Okay, it's got to be in line. Otherwise, when you rip the timber, the tendency, especially with wet timber, is when you go through the cut, it tends to bind at the back. And the moment it binds, the upward force of the blade tends to kick it back at the operator. So the job of this splitter is to actually keep the saw curve open and to prevent kickback towards the operator. Now, I am going to remove this for the simple reason that for today's demo, I actually need an open space above the blade. But under normal circumstances, if you rip or cross-cut, you will always have your splitter and your safety guard in place. Okay? Right, let me just take this. You will also see right next to your riving knife, you've got these anti-kickback fingers or pawls. In other words, when your piece of wood is going underneath your anti-kickback blade, the timber can't be kicked back towards the operator. So these two should also be in place there. Now, when it comes to picking a saw blade, it's very important that you spend as much time on picking a saw blade as you spend time on picking the actual machine. Because if you're not going to use the correct saw blade, you may have problems in future. Now, on every saw blade, they always specify the kind of blade, what it is. This one says framing and ripping. Now, framing is an American term for cross-cutting. So this is for cross-cutting and ripping. In other words, you can cut lengthwise as well as crosswise with this particular blade. Now, the whole theory behind this ripping or cross-cutting is relatively simple. If you take a ruler and you line up, let's say, the tip of that tooth to the center of your blade, lengthen that one. Now that is what we call the hook angle of the teeth. Okay, if that is below 30 degrees, it's a cross-cutting saw. If it's between 15 and 30, that is a combination saw or combination blade. If it's above 30, it becomes a pure ripping blade. If a person is swimming and the way he holds his hand in the water, that angle, that will drag the person forward, not so. We've got the very same situation with a blade. If that angle is a very steep angle, it rips better. And the saw will simply work better if you choose the correct blade for the correct application. You quite often find that if you are using a radial arm saw, that when you pull it through the timber, it tends to run up onto the wood. That is because you're using the wrong blade. It should not run onto the wood. That blade should be used on a normal circular saw for ripping only. This particular one is 300 millimeters. This is a 250 millimeters machine, so we cannot fit this blade onto this machine, because when you lower it, you will actually have a permanent piece of blade sticking out, and we don't want that. We want the blade to physically retract below the surface of the table when we lower it. In other words, it must go in like that. Okay? A few things on a circular saw that they always specify. The first one is 24T, that means the number of teeth on your blade. Then the 3.2, that is the thickness of the blade in millimeters. And they also tell you the diameter, the 300. Where it says bore, it says 30, then a stroke 25.4, stroke 20, stroke 16. It simply means that the hole there is 30 mils. Then they've got washers that has got an old 1-inch hole. So you simply put in the washer in the middle when you use it. You also get another washer with a 20 mil and one with a 16 millimeter hole. I'm going to go to a few, let's call it improvements or things that I find to be very useful. And the first thing that we quite often find irritating is the fact that you've got a wide gap around the blade on your insert. And what you should do is simply take a piece of medium density fiberboard and cut it so that it fits in, and now you've got a zero insert. That is always one of the first things I do whenever I buy a new saw. I make myself 3 or 4 of these. I've got one for vertical cutting, I've got one for 45 cutting, etc., etc. And something that works very well is a piece of offcut from these modern type of wooden flooring that you get. They are all 12 millimeters thick, and they're coated with melamine on both sides. Obviously on the top side you will have your wood grain finish. On the back side you've got a neutral brown. I find the brown looks actually very nice if you put that on top. Just be careful when you want to plane off that melamine surface. It's incredibly hard. So don't put it through your planer. It's going to damage your blades, I promise you. It happened to me. They are terribly hard. Rather take sandpaper and sand it off until you've got rid of that melamine surface. And once you break through to the normal medium fiberboard underneath, then you can put it through your planer. But not straight onto that. Right. Now, the first thing then would be a zero clearance insert that I would recommend. And then when it comes to cross-cutting, I find that instead of using your normal sliding miter gauge, I make myself what we call a sled. And this sled is simply a piece of MDF with these wooden strips that run into these grooves. Now there's a bit of a trick. The actual thickness of the wooden strips, they are quite a bit narrower than the gap. Right, now you will see there's a gap on the inside. In other words, these two strips, they are pressing against the outside. So when you find that it's not nice and smooth, you know that the strip must go towards the blade on either side. Okay, it's much easier. If you make them so that they are tight on both sides, then quite often you're not sure, must this piece of wood now go to the left or to the right. So make them narrower and always press out. So the left-hand side strip will be a permanent fixture. If you want to, you can glue it in place. The other one will have a slightly elongated hole, and this piece of strip can move to the left or to the right all the time. So only the outsides are now actually touching. Once you've made it like this, just coat it with normal wax. I find that this Woodok furniture wax works very well with this kind of job. And make sure it slides in and out easily. If you wiggle it like this, there should be no movement on it. And you find that this thing can be a tremendous help when it comes to cross-cutting. Now the main advantage is that if you do take a cross-cut, normally if you were to use your sliding miter gauge, that piece of wood that you cut off will now sit there, and when you bring your wood back, it will sit and fall into the opening or whatever, and it can be dangerous, can shoot back at you. But if you use this method, you actually bring that offcut back to you, and you can safely chuck it away. So this way of cross-cutting is a much safer method. Can you now see? You can now chuck it away without a problem. You're not trying to grab it right next to your saw blade. Right, now, in the same sense as this one is a permanent 90-degree cut, you can also have a permanent 45-degree cut. Okay, right now that's your 45-degree sled, okay? Now let's say, for example, you want to join these two pieces of wood at a 45-degree angle. It will be very easy to do it like this. Bring it back. Other one goes in from the other side. And you get your perfect 45-degree cut like that, okay? Now the advantage of working with this method is very simple, because if the blade is, for example, tilted and you don't know about it, and you're using your normal mitre gauge, you will set this to 45, and you will take your first cut, then you will take your other piece of wood, and you will also take your cut like that, not so. So when you bring the two together, that skewness is now doubled up. In other words, you've multiplied your mistake. In this method, if it's skewed like that, because the one is coming in from one side and the other one is coming in from the other side, that fault is actually cancelled out, okay? So that is the advantage of using this method of cutting. Now, if you want to, for example, join these two together, you can also make yourself a simple jig. Now, the jig I use for cutting a splice on a mitre is very simple to make. You start off with your, I call it the sort of base part of the jig, and this part will now clamp to that one, okay? So your piece of angled wood, simply insert it in here. One goes in the left side, other one in the right side. Bring them together like that. And we just clamp them together, tighten it up a bit, and now this is one solid unit. It's placed there, you just clamp it, and now you are ready to go. Now, positioning. First of all, let's just set the height of the blade, more or less there. Right. Now you can inspect the cut. If you want to make it a bit more to the left or to the right, you can move it a bit. Now the idea is to get an opening which is roughly in the 1/3 of the thickness of the wood. So once you've taken that first cut, we now flip the wood over. In other words, this one goes in there, that one goes in there. And we clamp it back in position. Now, because your fence hasn't moved, it's in exactly the same position. And we can just start it up again. And you will now see that you've got an opening which is perfectly symmetrical. In other words, in the middle of your piece of wood. Right. And you see there's your final joint. Now, all you now need to do is to cut a thin piece of wood, simply slip it in from the top and glue the whole thing together. In other words, basically something like that, okay? And just make sure that your grain is running that way. So this forms a very, very nice, strong, solid mitre joint. Right, now the next type of joint is one where I use the cross-cutting jig together with a simple setup like that. Here you can see you've only got an angled block of a piece of metal screwed into your wood, and the front part of the metal has been cut away so that you've got about a centimeter height sticking up. The thickness of the piece of metal must be slightly narrower than the thickness of your blade. Okay, that is fairly critical. Now just note that only the left-hand side, in other words, the left surface, will be a surface that stops the finger from moving. So the thickness of the piece of metal is not the critical part. The only critical part around that is that it should be thinner than your saw blade. But after that, you will only use the left-hand surface to act as a stop. You can, in theory, put a nail through there, and the left-hand side of the nail will now be a stopping surface. That's all we are really aiming for. Now, this is what I call my finger joint jig. The end result is something like that. You can see those are finger joints, and I'm going to show you now how to make those finger joints. Let me just get all my clamps here. Actually, small little G clamps that have been modified. You can see the top part has been cut off, and 10mm piece of wood has been, metal has been welded to it, and it now forms a nice clamp. The whole reason for that is that you want the front surface to be flush and open. That's why we cut it off. Now, the front piece of wood must be able to move to the left or to the right. That is the whole trick around it. And I've done a cut earlier, so I know more or less where to put it. So that one is right. Okay. Now you will see that the gap between the left surface and the right-hand surface of the blade is about the same, okay? And obviously the fixed component here will be the thickness of the blade, okay? That I can't adjust at this stage. Just cross-cut this to make it slightly shorter. Right, now we're going to set the height to be slightly higher than the thickness of the wood. It must stick out about 1 millimeter, and we lock it in place. Right, now when we start, we push it up so that it butts against that piece of metal. You take a cut like that, then it jumps over it like that. Right, now when you get to the last cut, you bring in the next block of wood, hold it in place, take the first one and turn it through 180 degrees, push it back into the last slot and bring the second one up. And now you take your cut. That simply means that where you've got a positive on the one side, you've got a negative on the other side, okay? Then you can put it to one side and you carry on with this one. There we go. You see? Perfect fit, doesn't fall out. And that is what we want with this finger joint. Now, these finger joints are incredibly strong if you use them as a corner joint. You can make jewelry boxes, whatever you want to do with this. You can even make wood lengthening joints simply by stretching it out, gluing it up, and now you've actually lengthened your piece of wood, and it would look much better than an ordinary butt joint if you want to join the timber together. Right, now this particular one, the idea was to make a hinge out of this and you simply round over and put a pin through it, and now this becomes a hinge. There's another example of this hinge. If you want the outside to look like a proper hinge, you can carve it a bit and round it over. Here's another idea. If you find that your blade is not very sharp and you have quite a number of breakouts on the bottom part, you can jippo later by simply cutting a groove there and gluing in a contrasting piece of wood. Then you actually cover up your mistake there, and it actually looks very nice. Now, here's another idea. With this particular one, what I did was to make a finger joint, but the whole joint was very loose fitting. So you start off with a thin layer of veneer, and you glue that onto the end grains of each and every one of those fingers there. And you do it on both sides. In other words, on the bottom part, you put your contrasting veneer. Then after that, you put in your other component, but now obviously it will be loose. So you slip it in, and then you slip in your veneer like that into those grooves. And when you finally sand it, that is the effect you get. In other words, it looks as if they are bricks with mortar in between. And it's very easy to achieve that. Simply make a loose fitting joint. In other words, you will move this piece of metal to the left so that your male part that you cut is smaller than the female groove created by the saw blade. Right. Take a look at this kind of joint. It's another corner joint. We call it a bridal joint. Again, you've got an opening there, and you've got the tenon there, and the question is now, how can we make them quick and easy without actually measuring a lot of things? First of all, we want to take the piece of wood and we want to move it across the blade with the wood standing upright like this. Okay, so again, you will bring in your fence and your piece of wood will be clamped like that. The idea is just to hold it in place, and now this forms one solid unit. Again, put it in the middle so that you get a symmetrical cut. We can just double check whether the height is correct. Slightly higher. Check. You can see that it's very safe to cut this way because your hands are far away from the blade. Now you can see that it's not 100% in the middle, so we have to flip it over like that, and we clamp it again. Now you can see it's symmetrical, but it's still a little bit too thin. So you can now just move your fence a little bit inwards or outwards, doesn't really matter. You go in a little bit inwards. There you've got your symmetrical opening, roughly about a third of the thickness of the wood, which is what we want. Now obviously if you are building furniture, this process will repeat it with all the different components that you want, because your setting is now 100% correct. Now when you want to make the male part that fits in there, in other words this part, is also now a quick way to do that. And for that we use our cross-cutting jig again. Can remove that. I'm going to use this to go in there. So what I do is first drop it to be a little bit below that opening. Right. That's the first thing. Then you take a piece of wood and you clamp it, so that piece of wood now forms a stop, and the length of that is slightly longer. We want it slightly longer than the thickness of the wood. The idea is that when you put these two together, that the end grain of that and the end grain of that will be slightly higher than the surrounding surfaces, so that you can only sand off those small little sections. That is the idea. Right. When we use a circular saw to cut a tenon, the general tendency is to use it like that. We first take a cross cut, and then we cross cut it like that, not so. But that is quite a tedious operation. It's much easier if you still do your two cross cuts on both sides, but instead of taking short little cross cuts, you actually go across the blade. In other words, you push it across the blade, okay? Now it creates quite a bit of dust, but it works very well. Now you can see that the thickness is still too thick, so I must just raise it slightly so that I've got a nice fitting joint. There we go. Still a little bit too thick. Not too bad, I'll say. But I think you get the idea there. Okay. Now that is the way to make a tenon in a very, very easy and quick manner. When it comes to making panels, we normally do this kind of cut on a big spindle machine with a special cutter. Okay. and it's actually a fairly dangerous operation to do it on a spindle machine because you're sitting with a fairly big cutter. Right, now you can use your circular saw blade to do this kind of cut. But the trick is that the approach towards the blade must be on an angle, okay? Now, all you really need is just a sturdy piece of wood that you will put on your saw table to act as a guide. I'm going to lower the blade first, and this piece of wood will now be clamped on the front portion of the fence. We can also put a clamp on the back part here.
45 degrees.
This angle it's not necessarily 45. It can in actual fact be any angle, because it's the same concept. If you take a round saucer and you look at the saucer on the edge, you simply see a vertical line. The more you tilt the saucer, the more of a curvature you see, not so. So you can create any kind of curvature depending on the actual angle. So the best thing is to actually play around and see what kind of curvature do you get at a certain angle. In actual fact, if you've got a solid piece of wood and you want to create a groove out of that, then it would be very easy simply to go down on your knees, look at the angle on your blade, and simply put a piece of wood on it and then just clamp it on that angle. But it's basically a question of trial and error until you get the correct angle, and then you simply make marks on your circular saw, and those marks you use for making panels all the time. Right, now the whole idea is that you will start off with your blade slightly raised. Then your first cut will be across the grain like that, and that's the kind of cut you get, okay? And that's your second one. After this, you now raise your blade a bit. Just be careful, don't raise it too much, okay? A little bit at a time. And again, cross grain first. You go a little bit higher. Now, we're aiming to get this section about 6 millimeters thick. Right, now if you look at the quality of this cut, you can see that it's fairly rough there, okay? So your last cut that you take, you will raise it slightly, and then you will take a fairly slow moving cut on it, and you will get a much finer finish. Can you see that cut is a much smoother cut than the previous one, simply because it's a finer cut. Right, I'm going to stop here, fairly close to 6 millimeters there, but the idea is that you will now learn how to use your circular saw also as a cove cutting device. Just one important point here. Always use the back part of the saw for this kind of cut. If you use the front part and you're actually standing on this side, then the blade tends to push this away from the fence. Okay. If you use the back part, it actually pulls it into the fence and you get a much smoother cut, much safer cut. But theoretically, both sides will actually work. It's just a matter of practicalities that we go for the back side of the blade. I just want to end off by saying that when you use your circular saw, always let common sense prevail all the time. If you're going to cut a heavy piece of wood, ask yourself, if I'm pushing this piece of wood through, what's going to happen when this piece of wood gets at the back? Will it fall over? Will I be able to hold it, etc., etc.? Ask yourself, if I push it through, what's going to happen to that small little block? Is it going maybe to shoot back against me, and so on. Also be very careful when you allow people that come into your shop, especially young children, not to warn them not to do, I don't want to call it simple things, because children don't think the same as what as what we think. We once had the case, I can still remember it clearly. I was cutting 70 by 70 blocks, the ends of these blocks for the kids at the school to turn. And I had a whole stack of them, and one by one I would cut them off, and this little sliver of wood will sit there. But as the next one comes in, this long train of blocks would just fall off at the end, and everything was going hunky-dory, no problem. And in comes the new batch of kids, and one guy took over from the other guy, and now he sees this block of wood sitting there. And he leans over from the other side and he grabs that block of wood next to the blade and he throws it away. And I said to him, "What are you doing?" He said, "Oh, sorry, sir," and he picks it up and he puts it back, right next to the blade. So kids do funny things. So especially if your grandchildren comes into your workshop trying to help you, tell them, listen, you may look at the saw, but there will be a block sitting there. Don't touch that block. I'm going to remove it. That kind of thing. Spell out the rules for it.